3-4, operating with scientific notation. So if you struggled with this, if you struggled with scientific notation and you didn't figure out what you did wrong, you need to come see me during power table. Alright, so what we're looking at today with operations with scientific notation is division. So we're going to divide scientific notated numbers. Okay, so the first example is 6.4 times 10 to the third over 1.6 times 10 to the 8th. Okay, so all you do is this. Everybody ready? Take your calculator.
Wait, I'm not ready.
If you need a calculator. This is a 3 here. That's an 8. Alright, so the first thing you do is you divide those two numbers, 6.4 times, or divide by 1.6. What does that give you?
Oh, I know what you get. Yeah, 4.
Wait, I'm not ready. I'm sorry.
Well, you actually get 0.0000.
Just a few questions.
All right.
You divide these first two numbers. That's the first thing you do. Now, this is just like we talked about with these exponents last week, dividing like bases. There's 3 tens on the top, there's 8 tens on the bottom. What happens when you reduce that? Where at?
8.
On the bottom. Except I don't want it on the bottom. So that's what she says. 3 of these 10s cancel with 3 of those, leaving 5 on the bottom. I don't want it on the bottom because I want this written in scientific notation. So what happens when I move it to the top? Yeah, it becomes a -5 on the top. Now, my question is this in scientific notation?
Yes.
Yes. You're done.
I've got a question.
Yes, Nancy.
How do you get the -5?
What you missed last week. 10 to the third means 10 times 10 times 10. This is 8 tens on the bottom. Don't 3 of those reduce with 3 on the bottom? Watch. You got 10, 3 tens on the top. I'm going to have 10 of these on the bottom, or excuse me, 8 of these on the bottom. And it's all multiplication. So what's 10 over 10? 1. So how many 10s are left? There's 5 of them left on the bottom, right?
Oh.
Alright, now what you missed is, if I want to move 10 to the 5th from the bottom to the top, it changes the sign of the exponent.
Oh.
If I want to move that to the bottom, it would change it to a positive. That's what you do with your bases.
Oh, yeah.
From last week, this part right here, the 10 to the -5. Did you know where we got the 4?
Yeah.
Okay, that part's okay. Alright. Let's review. There's 10 times 10 times 10 on the top. There's 8 tens on the bottom. That's what this is right here. You all understand that?
Yes.
10 over 10 is 1. How many tens are left? 5 tens on the bottom. Isn't that 10 to the 5th on the bottom?
Yeah.
Okay, but I don't want it on the bottom because that's not scientific notation. So I got to move that to the top, which makes it a negative exponent. Okay?
Oh, so like it would be 3 minus 8.
Yes.
Okay.
That's how you do it in the book. If you don't want anything in the denominator, you put the base on the top and take the top exponent minus the bottom.
Okay.
I just didn't share that with you because we weren't worried about that at the time. Yeah.
Can't you just
Yeah. Example 2. 3.48 times 10 to the third. This is going to be a little more difficult. 7.05 times 10 to the first. So do the first step and tell me what you get. 3.48 divided by 7.05.
Are we rounding?
No? Well, take it out 4 decimal places.
Oh, okay.
You should have gotten something like this.
You should have got
0.4936.
Yeah.
What I got?
1/7.
Oh, 9. Oh, 2, 1.
Okay. Just take it out 4 decimal places for now. Did you get this when you divided those?
Yeah.
Yeah.
Okay.
Oh, take it. Oh, okay.
Okay. Everybody all right? Did you divide those? Did everybody get this?
Yeah.
What are you doing?
Can I go on?
Yes.
Now, there's 3 10s on top. There's 1 on the bottom. Neffy,
Positive 2.
thank you.
There you go. Okay,
Now.
this is easy.
I thought
You're not done.
it was negative.
This number right here is not in scientific notation.
Okay, you're wrong.
Everybody look what I'm doing here. You have to make this number in scientific notation. Where's the decimal need to be?
By the, like, right in front, behind the 4, like in front of the 9.
Between the 4 and the 9.
Yeah.
So I gotta make this number 4.936, but that's not the same as this number. So what do I need to do to it? Multiply by a power of 10. What does it do to this decimal?
It moves it to the.
The left.
This 10 moves that decimal, not this one. That's where you guys are making your mistake. I'm multiplying this number times 10, not that one. I don't care what this decimal's doing. I care what this decimal's doing. This has got to be equal to that. So what does this decimal have to do?
Move it to the left.
How many places?
1.
That's why it's a -1.
So the answer is 4.936 times 10 -1. Oh wait, no, you have to multiply.
Still have to multiply by times 10 squared.
In division, will the exponent
Okay.
No.
I'm confused.
No.
Me too.
All right. Step 1. Divide those two numbers. You got this. Step 2. Figure out the 10. Can you do that? Step 3. If this number is not in scientific notation, it needs to be that way. So, can you convert a normal number into scientific notation?
Yes.
That's what we're doing right here in this step. I'm just making this number into scientific notation, but I still have to take that number times 10 squared, don't I?
Yeah.
It doesn't just disappear. All I did was drop it down here and rewrite this in scientific notation. Yes.
I had negative
Where? There?
2. Yeah.
Well, don't I have 3 10s on top and 1 on the bottom? No. Well, 3 minus 1 is 2,
Yeah.
not -2.
1 minus 3.
The reason it's negative here is because I have more on the bottom than I do on top.
Oh, yeah.
Yeah.
Wait, are you finished with that?
No, I got
Okay,
to do
well
this
then,
right here.
I'll let you.
But I want to make sure Hannah and them, they get this.
How did you get the, this was, I know you got it put in between the 4 and the 9, but how did you get that, yeah, that one? How did you?
Okay. In order to, 4.936 does not equal 0.4936, right? It has to. We have to make it equal. So that means I need to multiply 4.936 times 10 to some power to move this decimal back to there. All right? What happens when I figure this out? Don't I move that decimal 1 unit to the left? Isn't that where it's at? If I asked you this, and I said, put that in scientific notation, what would you tell me?
Put in between the 4 and the
I asked Hannah. Tell me.
Put in between the 4 and the 9.
Okay, and then what? I just can't move it. I mean, those two are not the same, are they? I have to multiply this one times the power of 10. What's the power? What's the exponent? Why?
Because when you have to make it back in a regular number.
It has to equal this.
Yeah.
If that was a positive one, wouldn't it make this decimal move to the right?
Yes.
Okay, that's where this came from. These two numbers are the same. But aren't I taking that number times 10 to the second? So don't I need to take this number times 10 to the second? Okay. That's all you're doing. Now, what is this? You're multiplying like bases. What do you do with your exponents? You add them. What's -1 plus 2?
1.
Now you're done. That's your answer.
What the heck?
Wait, but
Yes.
I don't get how you got the 10, -1.
Right here. If you had to put this number in scientific notation, the decimal goes between the 4 and the 9.
Oh, yeah.
Well,
You just had that.
how does this decimal get back to where it came from? It has to move to the left one, right?
And if it goes that way, it's negative. If it goes that
Yeah.
way.
From your answer, you gotta work it backwards. From your answer back to here, what does it do? Okay, yes.
There you subtract down there, so add
Where?
the 3 and the 1.
Oh my.
Because you're dividing.
If you're gonna keep your base on the top, you subtract your exponents. I just don't teach it like that because it confuses everybody. If that's the way you wanna do it, that's fine. Okay? Ready? Let's do another one. Is everybody okay with the division or not?
Wait, yeah, I'm okay, but how'd you come to, so you mainly got the same thing, like, how'd you move it to 0.4936 and then move it back to,
Well, to get that, I divided these two numbers.
yeah, I know,
And I looked at it and said, well, this is not scientific notation.
yeah, I know.
Well, I gotta make this number in scientific notation, which is what I did here. Didn't I?
Yeah, but then, what did you do with that -1 and 2?
Well,
Is that how it came, like, scientific notation?
well, this -1 came from putting this into scientific notation. Yes?
Okay,
Oh, you moved it
you like just lost me with that.
This number in scientific notation is the same as this, right?
Yeah.
Yes or no? You either understand it or you don't. Well, aren't I taking that number times 10 squared? And isn't this the same as that? I'm just substituting this in that position. So that's why that 10 squared is there. Is this and that the same thing?
Yes!
Well, are you telling me that the 10 squared disappears from here to here?
No!
No, this is the next step. Okay, so the 1 comes from putting these two together.
Oh.
This number times 10 squared gives me times 10 to the first power. Maybe if you would have done your homework last week, you wouldn't have that question.
What, Fridays?
Example 3,
So,
multiplication.
I'm entirely.
6.3 times 10 squared times 0.00132 times 10 to the 4th. Step 1, just like in division, I divided these two numbers. I'm going to multiply these two numbers, 6.3 times 0.00132. Everybody do that on your calculator. Now, I went over this Friday in your notes, but not with these types of numbers. What do you get when you multiply those two numbers?
0.008316.
Thank you.
Oh, snap.
Now, that's just those two numbers multiplied together.
You supposed to multiply together?
Oh.
This is a division symbol. There's
Yeah.
nothing in here, that's multiplication.
Yeah. Okay.
Now, you still have these 10s to multiply together. Aren't they like bases?
Yeah.
What do you do when you multiply like bases?
Add them.
So what do you get?
2, 6.
Okay. Great. We're back at where we were over here.
I don't want to. No, I'm not. Nobody wants to.
Not an option. Not an option. Great.
What?
I'm trying to help you. Look up here. This is your last chance. Participate. Let me help you. Okay? Look up here. We are at this step where we have a number that's not in scientific notation, and you agree with that. Is this number in scientific notation? This number right here, just this. Is that in scientific notation? What are the rules for something being in scientific notation? What's rule 1?
Must only have one number left to the decimal, can't be 0.
Right. Well, the number left in the decimal is a 0 here. So this is not in scientific notation. What's rule number 2?
Must be multiplied by the power of 10.
Which we do have that. But rule number 1 is not met yet. So just look at this number right here. Let's say I gave that number to you and said, put that number in scientific notation. Where would the decimal need to be? Right.
To the right.
To the right where?
Between 8 and 3.
Yeah. So it would be 8.316. But this number doesn't equal that number, right? These are two different numbers. Until I multiply this number by a power of 10, right? Now, this 10 is going to move this decimal. What direction? Where do you want it to be? For these two numbers to be equal, where does that decimal have to go?
To the right.
This decimal has to go to the right. Where does it have to go? How many places? So if the decimal's here, that's where you're saying it needs to be. Where does it have to go to get back to here? How many places? 1, 2, 3. And since you said left, that's a negative. So now, this number right here is the same as this number in the rectangle. Does everybody understand that? Okay, now don't I need to take that number times 10 to the 6th? Now, these two lines, this one here and this one, are exactly the same numbers. We just manipulated where the decimal's at. This is good stuff. We're moving on from just saying whether something's in scientific notation. We're manipulating all this stuff. Now the next step, you're almost done. You have to combine like bases. What do you do with your exponents when you multiply like bases?
Add.
So what do you get? 3. -3 plus 6 is positive 3. Now that is your answer to that problem. Yep. Your assignment. Page 107, 2 to 3 evens. Guys,